Hello students, how are you all? I hope that you all are good. As we know, we are successfully finished the motion in a straight line chapter. In a last lecture that we are discussed about some important selected JEE mains previous year questions. I hope that you are enjoyed the lectures. Okay. So from today onwards that we are going to start the new chapter that is a motion in a plane. Okay. So whatever the things that we are discussed in a previous chapter like a position, acceleration, velocity, speed, distance, displacement, all these things can be used to describe the motion of an object along a straight line. Okay, but in this chapter, to describe the motion of an object in a two dimension or in a three dimension or a space, so we have to know about our vectors. Okay, we must depends upon vectors to describe the motion of an object in a plane or space or two dimension or three dimension. So for that, from today onwards, I'm going to start the concept of vectors. Okay, in this session, mainly that we are going to discuss about what is vector, what are the types of vectors. These two things that we are going to discuss in today's lecture. Okay, shall we start the session? Right. So my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Shall we start the chapter? Right. So what is the chapter? Motion in a plane. Motion in a plane. So this is a class number 101. Okay. Right. So before going to discuss about vectors, we have one small concept that is scalars. Okay. What is the meaning of scalars? Already I told you in a distance and displacement concept. What is a scalar? What is vector? Have a look. Scalar means the physical quantity, having only magnitude, only magnitude, but not direction. Such type of quantities are called what? Scalars. Okay, right. So the physical quantities are having the only magnitude but not direction. Have a look. I'm taking one example. So what is the meaning of magnitude? So magnitude is nothing but constant value. What is magnitude? Magnitude is nothing but it is a constant value. Have a look. I'm taking the example. Here there is a bike. Okay. So this bike is moving with a speed of 5 meters per second. So what is the speed of the bike? 5 meters per second. Just saying that the bike is moving with a 5 meters per second speed. That's it. In which direction it is moving? I'm not mentioned. So the direction of the bike is not mentioned. Okay. Only it has a magnitude. Magnitude means it's a constant value. This is what? Magnitude. But the direction of this bike we are not mentioned. Okay. So that means whatever the physical quantity we are taken, that is what? Scalar physical quantity. That means speed is a scalar quantity. Speed is what? Scalar quantity, because we are not mentioned its direction. Okay, I'm just saying that the bike is moving with a 5 meters per second speed. That's it. In which direction it is moving? We are mentioned? No. That's why this 5 meters per second is called what? Speed. What is speed? It is a scalar quantity. Why it is scalar quantity? It is not having the direction. Are you getting? Right. So the examples for scalars are mass, length, okay, time, distance, okay, speed, work, density, and so on. So all these are what? Examples for scalar quantities. Okay, note the operations of mathematical operations of scalars gives scalar. The mathematical operations of scalars gives what? Scalars only. Addition of two scalars, you will get the answer again scalar quantity. If you multiply the two scalars, you will get the answer in terms of scalars only. If you are divide the two scalars, again you will get the answer in terms of scalars only. Okay. To solve scalars, we use simple mathematical operations like addition, subtraction, multiplication, and the division. We use simple mathematical operations. Okay, right. Next one. So what is that? Unit is not compulsion, not compulsion to represent a scalar quantity. Okay, so unit is not compulsion to represent a scalar quantity. For example, if you take a refractive index, so refractive index is not having any unit because so refractive index is nothing but what? The ratio of speed of light in vacuum to speed of light in a medium. Okay, so have a look for this speed of light in a space. How much? Meter per second. The unit for this meter per second. So meter per second get cancelled. So refractive index has no units and it is a scalar quantity. Have a look. Here speed is a scalar quantity. It is having the units. That means maybe the scalar quantity having the units or may not be it having the units. So second example of specific gravity. Okay, specific gravity. And we have one more example, that is a strain. Okay, what is strain? The ratio of changing length to original length. Okay, the ratio of changing dimension of the object to its original dimension is called what? Strain. So for length, what is the unit? Meter. For length, meter. Have a look. Strain is also not having any unit, but it is a scalar quantity. That means maybe scalar quantity has the unit or may not be it has a unit. Okay. So this is about a scalar physical quantities. Okay, small lecture. Right. So pause the video and write the notes. 3, 2, 1, go. Right. So let us we discuss about vectors. Okay, have a look. Vectors. What is the meaning of vectors? So what is the meaning of vectors? Have a look. A physical quantity. A physical quantity having both direction, and magnitude. Both direction and magnitude is called what? Is called a vector. Is called a vector. Right? So, what is the meaning of vectors? A physical quantity having both direction and magnitude. A physical quantity having both direction and magnitude. Such type of physical quantity is called what? Vector quantity. Have a look. I'm taking the example. Okay. Right. So, in this example, I'm taking the bike. Okay. Right. A bike is moving with a velocity 5 meters per second. 5 meters per second in east direction. In east direction. Right. So in a previous example, whatever the bike we are taken, it has only 5 meter per second speed. Okay, now, but we are not mentioned the direction. That's why it is called a speed. Why it is called a speed? It has no direction, and the speed is a scalar quantity. It has only magnitude but not direction. But here we are called this physical quantity as a velocity. Velocity. Why we are call it as a velocity? Velocity is a vector quantity because it has both magnitude. What is magnitude? Magnitude is nothing but what? Constant value. It has magnitude as well as direction. So now this physical quantity is called what? Velocity. Velocity is a vector quantity because it has both direction and magnitude. Okay, right. Let us see the examples for vector quantity. Examples. Okay, right. So displacement is a vector quantity. Displacement. Okay, acceleration. Acceleration is also vector quantity. Velocity. Velocity is also a vector quantity. Force. Force is also a vector quantity, and so on. So these are the examples for what? Vector physical quantities. Okay, right. Note symbol. Okay, so symbol of vector can be represented by an arrow. So this is what? This is the symbol of a vector quantity. Okay, arrow. So have a look. This part, this straight line. So this straight line is called a tail. This straight line is called what? Tail. And it represents, and it represents magnitude. It represents what? Magnitude. Okay. And this arrow symbol is called a head. This is called what? Head. And it represents direction. Let us look. It represents direction. It represents what now? Direction. Okay, so this straight line is called what? This straight line is called what? Tail. What is it represents? Magnitude. This arrow is called what? Head. What is it represents? It represents the direction of a given physical quantity. Okay, note number 1. Okay, right. Have a look. A physical quantity, a physical quantity, although having both direction and magnitude, both direction and magnitude, but if it not obeys law of vector addition, then that quantity, then that, let us say physical quantity, then that physical quantity is called a scalar. LAR is called a scalar quantity. Right. So what is the note? A physical quantity, although having both direction and magnitude, a physical quantity having both direction and magnitude, but it not obeys law of vector addition. It does not obeys the laws of vector addition. Then the physical quantity is called what? Scalar quantity. Although it has both direction and magnitude, but it does not obeys vector addition, law of vector addition. Then we are treated it as scalar quantity. Have a look. Example: electric current. Electric current. So, according to Kirchhoff's law, we can say that a current is moving towards the junction. Let us call this point is as a junction, and towards the junction, the current I1 is moving like this, and the current I2 is moving like this. Okay. So finally, the resultant current in this conductor, I net or I resultant, is equals to how much? I1 plus I2. I1 plus I2. Have a look. Here the current I1 and the current I2 are making an angle theta at the junction. But we wrote the equation for resultant current is equals to how much? I1 plus I2. That means this resultant, I resultant, is not depends on theta. It does not depends upon theta. Have a look. Any theta term is there? No theta term is there. So that's why it is not depends on theta. Then it does not obeys law of vector addition, law of vector addition. Then electric current is a scalar quantity. Okay, right. Are you getting? So what is the meaning of vector? A physical quantity having both direction and magnitude. Such type of physical quantity is called what? Vector quantity. So example, here we are taking the bike. This bike has a 5 meter per second velocity. Why we are call it as velocity? It has both direction as well as magnitude. So that means velocity is a vector quantity. Okay. So examples, displacement, acceleration, velocity, force, and all these things are belongs to what? Examples for vectors, physical quantities. Okay. Note, symbol of vector is represented by an arrow. So this straight line represents what? Magnitude, and it is called what? Tail. This arrow represents what? Direction, and it is called what? Head. Arrow is called what? Arrow symbol is called what? Head, and this is called what? Tail. So note, a physical quantity, although a physical quantity is having both direction and magnitude, if it does not obey laws of vector addition, then that quantity can be treated as what? Scalar. For example, if you take the electric current, so although the electric current having the direction, have a look, it has a direction and it has some magnitude, but it does not obey the laws of vector addition. Whatever the resultant we are taken, it does not depends upon an angle theta where the two currents are made. So that's why an electric current can be treated as what? Scalar quantity. Are you getting? Any doubts? Right. So pause the video and write the notes. 3, 2, 1, go. Right. So let us we discuss about types of vectors. Okay. Types of vectors. Types of vectors. Right. Have a look. The first one. Okay. The first type of vector is what? Parallel vectors. Parallel vectors. So what is the meaning of parallel vectors? Have a look. I'm just to draw the diagram. Then you can understand clearly. Okay. I'm taking the vector A bar. Okay. So another vector I'm taking of B bar vector. Have a look. Compare with A bar vector, the magnitude of the B bar vector is small. That means in case of parallel vectors, the magnitude of the of the two vectors is what? Different. Is different. Magnitude of the two vectors is different. But important. But their direction, but their direction is is same, but their direction is same. Here the magnitude is different. Have a look. So the tail of this b bar vector is small compared with the tail of vector a bar. So what is the tail gives? The tail represents what? Magnitude. Have a look. The magnitude of a bar vector is greater than the magnitude of the b bar vector. Now angle between them, what is the angle between them? Angle between a bar and the b bar vector is how much? Is equals to 0 degrees. Is equals to how much, ma? 0 degrees. Have a look. They are parallel to each other. Okay, now. So the angle between the two parallel vectors is equals to how much? 0 degrees. Are you getting? Any doubts? Okay, very good. La, 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 la. Right. So second one, I'm taking off anti-parallel vectors. Anti-parallel vectors. What is the meaning of anti-parallel vectors? Okay, again I'm going to draw the diagram, then you can understand easily. So let us consider this is a bar vector. Okay, and this is what? B bar vector. This is what? B bar vector. Have a look. Again, the magnitude of the two vectors. Magnitude of the two vectors is what? Different. So compare with the magnitude of A, the magnitude of the B is small, and the direction is what? Opposite to each other. opposite to each other. Have a look. The direction of A bar vector is in direction. The direction of B bar vector is in this direction. So both are having a opposite direction, not a different direction, having opposite direction. So angle between A bar and B bar vector, how much? 180 degrees. So theta is equals to how much, mark? 180 degrees, because they are anti-parallel to each other. Have a look. Let us consider this is A bar vector and this is a B bar vector. Okay. So both are in a opposite direction. So angle between them is how much? 180 degrees. Likewise, you have to take an angle. Okay. Right. So third one, I'm taking a equal vectors. What is that? Equal vectors. Right. So what is the meaning of equal vectors? Have a look. So let us consider this is a bar vector and this is B bar vector. A bar vector and the B bar vector. Now these two vectors are called equal vectors. These two vectors are called what? Equal vectors. Why we are called that as equal vectors? Have a look. Their magnitude. Magnitude is equals to how much? Same. Magnitude of the two vectors is same. And their direction. And their direction is also same. Direction is also what? Same. Okay. So angle between them is equals to theta is equals to how much? 0 degrees, because they both are acting in a same direction. Both are acting in a same direction. So the angle between them is how much? 0 degrees. Have a look. The magnitude of the two vectors is same. The direction of the two vectors is same, and angle between them is how much? 0 degrees. Then this type of vectors are called what? Equal vectors. Also, the equal vectors also like this. Okay. So this is a bar vector, and this is what? B bar vector. So you can also draw in this direction. Okay. So have a look. The magnitude of the two vectors is same. The direction of the two vectors is same, and the angle between them is equals to 0. So then these two vectors are called what? Equal vectors. Okay. Have a look. The difference between parallel and equal vectors. So here everything is same. Direction same. Direction same. Okay. Angle between them is 0 degrees. Here also angle between them is 0 degrees. But in case of equal vectors, their magnitude is same. In case of parallel vectors, their magnitude is different. This is a small difference between what? Parallel and equal vectors. Okay, right, very good. Fourth one, non-equal, non-equal are negative vectors. Or what? Negative vector. Have a look. What is the meaning of non-equal or negative vectors? Have a look. I'm drawing the diagram. This is a bar vector. Okay. And this is what? B bar vector. This is what? B bar vector. Have a look. Now these two are called what? Non-equal or negative vectors. Non-equal or negative vectors. Have a look. Their magnitude. Their magnitude is equals to how much? Same or different? See, from here to here, from here to here. The magnitude is same. The tails of the two vectors is equals to same. If the tails of the two vectors is same, then their magnitude is also same. So the magnitude is equals to how much? Same. Direction. The direction is equals to, have a look. This is the direction of vector A bar and this is the direction of vector B bar. Then they are opposite to each other. Then they are what? Opposite to each other. And the angle between them, theta is equals to, in case of opposite vectors, what is the angle between them? Theta is equals to 180 degrees. But have a look. In case of equal vectors, these two vectors having the same direction and the same magnitude. So that's why here we can write out vector A bar is equals to vector B bar. Can we write like this? Have a look. Their magnitude same, their direction same, and angle between them is 0. Then vector A bar is equals to, we can write vector B bar. But have a look. Here the magnitude of the two vectors is same. Only the direction is what? Opposite. Then we can write like this. Vector A bar is equals to B bar. Vector A bar is equals to B bar vector. But the direction is what? Opposite. The direction is what? Opposite. So that's why here I am taking negative sign. Vector A bar is equals to B bar. Their magnitude is the same, but opposite in direction. So whatever the negative sign we are taken in front of B, that negative sign shows this vector A bar is equals to B bar, but in an opposite direction. So negative sign shows what? Opposite direction, and it is called what? Negative vector or non-equal vector. So let me discuss about a fifth vector. So what is that? What is the fifth vector? Right. Co-initial vectors. Co-initial vectors. Right. What is the meaning of co-initial vectors? Have a look. Just to draw the diagram. This is A bar vector. This is B bar vector. This is C bar vector. Okay. So this is what point. So now these three vectors are called what? Co-initial vectors. Co-initial vectors. Co-initial means what? The vectors having same initial point. Same initial point. Such type of vectors is called a co-initial vectors. Are you getting? The vectors having a same initial point, although their magnitude is different, their direction is also different, but they must travel from, they must move from same initial point. Have a look. A bar, B bar, C bar, all are moving from same point O. That's why they are called what? Co-initial vectors. Are you getting? Any doubts? Let us see sixth one. Co-planar vectors. Co-planar vectors. If any spelling mistakes are there, please excuse. Okay, coplanar vectors. Have a look. I'm taking the two-dimensional coordinate system. Let us say this is x-axis and this is y-axis, and this plane represents what? XY plane. If the two vectors or two or more vectors are lies in a same plane, okay. If two or more vectors, if two or more vectors lies in a same plane, in a same plane, then they are called what? Co-planar vectors. Okay, if two or more vectors lies in a same plane. Okay, so if you take any two vectors, that two vectors are lies in a same plane. So if the vectors lies in a same plane, such type of vectors is called what? Co-planar vectors. Okay, are you getting? Any doubts? Right. So pause the video and write the notes. I hope that you are clear about this six vectors. Okay, right. So pause the video and write the notes. 3, 2, 1, go. Co-linear vectors. Is that co-linear vectors? What is the meaning of co-linear vectors? Have a look. If the vectors, if the vectors acts along a straight line, acts along a straight line, then the vectors are called what? Co-linear vectors. Okay. If the vectors are acts along a straight line, then such type of vectors are called what? Co-linear vectors. Right. Let us see the examples for co-linear vectors. So have a look. So this is a vector A bar, and this is the vector B bar. So have a look. These two vectors are acting along a straight line. Acting along a straight line. Then these two vectors are called what? Co-linear vectors. Are you getting me? Or if the diagram is like this, if this is A bar vector and this is a B bar vector, A bar vector and B bar vector. Have a look. These two vectors are also acting along a straight line. So these two vectors is also called as what? Co-linear vectors. Are you getting? Any doubts? Okay. So what is the angle between these two vectors? Have a look. Theta is equals to 180 degrees. So the angle between head and tail, always you should remember the angle between two heads or two tails. The angle between two heads or two tails is equals to how much? 180 degrees. And the angle between one head and one head and one tail is equals to 0 degrees. Okay, 0 degrees. Angle between head and head, angle between head and head or tail and tail is equals to how much? 180 degrees. Or the angle between tail and head or head and tail is equals to 0 degrees. You should remember this. Okay, so the angle between two heads or two tails, 180 degrees. The angle between head and tail or tail and head, 0 degrees. Is it clear? Right. And go with the eighth vector, that is a real or polar vectors. Real or polar vectors. Real or polar vectors means if the direction of the if the direction of the vectors does not changes although the coordinate system changes. If you change the coordinate system of the vectors, if their direction does not changes, such type of vectors is called what? Polar or real vectors. Examples: force, acceleration, okay, momentum, and so on. So these are the examples for what? Polar or real vectors. Okay, right. So let us see the ninth vector. Right. So let us see the ninth vector, that is a axial or pseudo vectors. Okay, axial or pseudo vector. That means if the direction of if the direction of vectors changes when the coordinate system when the coordinate system changes. Okay, so if the direction of the vectors changes when the coordinate system is changes, such type of vectors is called what? Axial or pseudo vector. So examples: torque, okay, angular acceleration, okay, so next angular momentum, and so on. Okay, so let us see the 10th one, important one. So null vector or zero vector. Null vector or zero vector. What is the meaning of null vector or zero vector? Have a look. The vector whose magnitude is zero. The vector whose magnitude is zero. Such type of vector is called a zero or null vector. Zero or null vector. Are you getting? A vector whose magnitude is zero. Such type of vector is said to be what? Zero vector or null vector. Have a look. Okay. So null vector is represented by zero bar. Is represented by what? Zero bar. Okay. Have a look. Rules of null vectors. So rules of null vectors. If a bar is a vector, if you add null vector to a bar vector, so you will get a bar vector. Okay, so this is what first rule. And I'm taking the second rule. If the vector a bar is multiplied by zero vector, then you will get 0 vector. Then you will get what now? 0 vectors. Are you getting? Any difficulty is there? Right. Very good. So let us see the 11th type of vector, that is a unit vector. What is that? Unit vector. Unit means what? 1. Unit means what? 1. So unit vector means a vector whose magnitude is said to be is said to be 1. A vector whose magnitude is said to be 1, then it is called a then it is called what? Unit vector. Then it is called what now? Unit vector. Okay, are you getting? Any doubts? Okay, very good. You are a good student now. You are understand every concept easily, right? Okay, I'm just joking, huh? So symbol of unit vector. So the symbol of unit vector is what? Cap. So this is the symbol of unit vector, and it is called what? Cap. A cap, B cap, C cap, like that. Okay. Right. Next formula. So let A cap is a unit vector. Let A cap unit vector. Okay. Then the formula for this unit vector, A cap is equals to, we can write vector A bar by magnitude of A. Vector A bar by magnitude of A. So this is the formula for what? Unit vector. Vector A cap is equals to A bar by magnitude of A. Okay. Next, unit vector. Unit vector can be used to represent the direction of the direction a given quantity, physical quantity. Okay. So unit vector can be used to represent the direction of a given physical quantity. So why we are used the unit vector? It can be used to show the direction of a physical quantity. It represents the direction. Okay. Are you getting? Right. So if I take a rectangular coordinate system, so this rectangular coordinate system consisting of x comma y comma z axes. We know that. So this is what? X axis. This is what? Y axis. X axis, Y axis, and this is what? Z axis. Are you able to see the board? Okay. Z axis. So have a look. This is called what? Origin, or fixed point. Already we are discussed. So here I am taking along x axis. The unit vector is I cap. Okay, unit vector is what? I cap. Along y axis, I am taking the unit vector is j cap, and along z direction, the unit vector is k cap. Okay, so I cap is the unit vector which shows the direction of a given physical quantity along x direction. If you write the vector like this, a I cap. Okay, a I cap. So that means a is a physical quantity. In which direction it is acting? Along x direction, positive x axis. If you take a minus a I cap, so A is a physical quantity. In which direction it is acting? It is acting along a negative x direction. Minus I cap means what? This physical quantity is acting along a negative x direction. Are you getting? So what is unit vector? Unit vector gives the direction of a given physical quantity. I cap is the unit vector along x axis. J cap is the unit vector along y axis. And k cap is the unit vector along z axis. Positive x, positive y, and positive z axis. Are you getting? Any doubt? Now what is the direction of the null vector? So it has an arbitrary direction. Its direction is an arbitrary. So arbitrary means what? Any direction. Okay, arbitrary means what? Any direction. But the unit vector represents one particular direction. Either it is positive x, positive y, or positive z, negative x, negative y, negative z, whatever it is. Okay, are you getting? Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So this is the end of the today's lecture. We will meet on a next lecture, that is a motion in a plane 0 to one small concept is there, parallel shifting of the vectors, and some examples are there, finding the angle between the two vectors. Okay, so that is a small concept, maybe it takes 10 to 15 minutes. Okay, so we will meet on that lecture. Okay, so I hope that you understood what is scalars, what is vectors, what are the type of vectors, and all these things. Okay, so write the notes clearly and neatly, right? So this is the end of the today's session, and this is Rakesh Kanaganti signing off. Jai Hind.